As part of the Ancient Connection project, we are striving to revive the ancient links between North Wexford and North Pembrokeshire, and this includes looking at the buildings within these areas. Here we shall look at the evolution of our buildings, at the story of how buildings, predominantly domestic but including agricultural and industrial buildings in Pembrokeshire and Wexford, have developed, and how the styles have changed over time. We will be looking at the similarities due to the climate, location, geology and fashion, and also the materials, the traditional materials that have withstood the test of time: earth, lime, stone, timber, which in turn have led to the common external finishes in these two regions. From the Iron Age and earlier, settlements that grew up in Pembrokeshire and Wexford were similar in style, construction and materials. Having similar geology and climate, as well as a coastal location, dictated which resources were available. And the structures like the roundhouse at Castell Henllys would have been the norm during this early period. Due to the climate in these exposed coastal areas, long, straight oak timbers were and still are at a premium. This is partly why Iron Age roundhouses had round pole roofs, and there are no early timber frame buildings surviving in Pembrokeshire and Wexford. Lime has been used as a binder in construction for many centuries, if not millennia, and lime kilns where the limestone is burnt can be found throughout the coastline as well as inland. The raw materials were burnt to form quicklime, which was slaked to a putty or used as a hot mix mortar for building, for pointing and plastering mortars, as well as for lime washes. The types of stone used for construction of our buildings has an impact upon their appearance. From random river rubble, bedded cut slate to coarse dressed stone, each has its own aesthetic that can be impacted upon by the mortar used for pointing, and also the surface finish of the pointing. So whether recessed, flush or proud, the colour, derived from the aggregates used, and the particle size all have some impact upon how the finished article looks. For added protection from the elements, wind, rain and salt in coastal locations, various surface treatments and finishes have been used in both Pembrokeshire and Wexford. Layers of pure lime wash, with or without local mineral pigments that have a soft natural finish, often with distinctive regional colours, is the basic protective layer that was and still is applied to stonework. Stepping up from a simple lime washing is the shelter coat, lime wash that has been bulked out with a fine sand and that is applied to the whole masonry surface, which creates slightly more surface area and therefore more rain protection. Local variations of this include a bagged finish, where a lime slurry, a lime wash that has even more sand in it, is applied to the wall and then spread over the surface, usually with a Hessian sacking. This is quite a common finish to agricultural masonry. Here we are in wet, as usual, West Wales, and what we've got on this gable end of this house, which gets all the weather, there's going to be a ground floor building here, structure built here, and above where it gets all that weather, the wall has been harled. So this is a wet dash of lime plaster with coarse aggregate on the stonework in 3 coats. There's a base coat levelling out layer, and then there is this deep surfaced rough cast. Harling, another term for it, which we use generally for this type of plaster finish. This has had a lime wash on top as a bit more protection, and what it does is it allows the building to accept more rain because of the surface area, and also it dries out more quickly because of the surface area. This layer of render is actually acting as a poultice and drying the walls. It's actually pulling moisture out of the walls, and it's thrown onto the walls in the layers. So there's energy put onto that as it's put in place. As I've just said, in 3 layers, so it's quite deep. So here we have another traditional Westphalian finish of the outside of a building. You've got the natural stone, you've got a bedded stone where you can actually see all the sedimentary layers in the stone itself, and you can see how it's been hand cut. Some of this is weathered, others of it, this is the actual surface dressing of the stonework to give it an effect. This isn't just cut like this, it's done to give it an effect, all by hand, and it is then flush pointed with a lime mortar. And you can see it's done really cleanly, but the lime mortar with a coarse aggregate is acting as a poultice again. It's allowing moisture to be drawn out rather than going through these dense stone units. So it's very neat and it's very locally traditional. You don't see this, you wouldn't see this where there's a different type of stonework. So it's dressed, faced, bedded, lime mortared stone wall. Another example of a rough cast, wet dashed, hulled wall where the wall is a natural stone, a more rubbly stone wall, so it's more uneven. It hasn't been levelled, it hasn't been plumbed or flattened, it's just followed the contours. Each stone, you can see its shape behind the plaster, but there's still 3 layers of this on top of a repoint and dubbing out layer, giving this really coarse textured surface which will shed water. In this instance, this hasn't been lime washed. It probably will be in the future, but there is a risk that the lime wash can start filling these pores and holes if it's not done well. As fashion changed and status improved, usually in the more affluent towns and ports, the rendered surfaces became more consistent and ostentatious, some having floated smooth render finishes, others stepping up to the more sterilised ashlar renders imitating expensive dressed stonework. In conclusion, it is clear that there are many connections and similarities with the traditional buildings from these 2 regions, and we therefore need trained and skilled craftspeople to look after and care for these buildings using appropriate traditional skills and materials.